So, so when we talk about memory size. Okay, so let's get into the fun stuff. Now, I'm going to start this with starting with a numbering system that we all know and learned in kindergarten. Okay? Now, before we left decimal, what are the possible digits in decimal? What are the possible digits in a decimal number? 0 through 9. So let's count in decimal. You ready? Okay, so what comes after 9? Okay, so how do I know that? Can you give me a logical explanation of why I'm going from 9 to 10? Because what? Yeah, so I'm out of digits. Does everybody agree I'm out of digits? 0 through 9. So I have to leave the ones column and put a digit in the tens column and then start over at 0 in the ones. I mean, you know this. We're just formalizing it, right? Okay? All right, and in kindergarten you might have had like you remember how you used to use the red pins and the blue pins for the, the ones and the tens, okay? But basically what we're doing is we're out of digits, we're going to the next number column. All right, so then everybody knows what's next. It's 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. I didn't run out of space. Congratulations. Okay. So that's all well and good, and we all know that, and we do that because I don't know why they decided we had 10 fingers, 10 toes. I mean, somewhere along the way, base 10 was defined as the standard. Okay. So what I want everybody to do now is remember all the facts we just said about base 10. Because what we're going to do now is change the base, but take the same rules. You with me? You ready? Okay. So let's take a binary number, which is the first base we're going to look at. What type of values can the computer store? I forget. What were the values the computer can store? Okay, the computer can store 0 and 1. So what base does that mean is going to work in this situation? Base 2. And that means that, what is base 2? What numbering system is base 2? Binary. Okay? So let's count in binary. You ready? Let's count in binary. Okay? First comes, then comes 1. Okay, why? You're correct, but why 1, 0? Why is 1, 0 next? I'm out of digits, so I have to go over to the next placeholder. Give them a minute. Give them a minute to think about this, okay? So it's 0, 1, 1, 0, 1, 1. We're out of digits, so now we do what? Over to the next placeholder, okay? Do you know what comes next? 1, 0, 1. We're starting over in the ones column. Okay? Now we're out of digits here, so we're going to go to 1, 1, 0. The next one's easy, I think. Okay? And then we're out of digits, so we have to go over to the next. Okay, what do you think comes next? 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. I'm going to move this so that can show up in the camera. 1 1 0 0 1 1 0 1 1 1 1 0, and then what's 16 going to be? 1 and okay. Binary values from 0 through 16. Okay? Sorta, kinda. So now, let's talk about how we're going to go from binary to decimal. So if I put up this number right here, it looks like a binary number, but the way to be sure that it's a binary number is to put a 2 as a subscript right here. That indicates it's a base 2 number. Does that make sense? Does that make sense? So now, this time, the value here is 0, and what am I going to multiply this time? What base is this? 2. And which guy is this? What did we do when we did tens? I hear a lot of mumbling. 2 to the 0, which is 1. Okay? That equals 0. Let's carry down. The 1 is the digit. We're going to multiply that times what? 2 to the 1, which is 2. So what's the answer here? This guy is a 0. What are we going to multiply this times? And but the bottom line is the answer is bring down the digit, which is 1. 2 to the what? 3rd, which is what's this one? Which is, we add this sucker up, 10 and 6, carry the 1, 26, base 10. Question? You did it just on top of the number? You're essentially doing the same thing. So if that works for you, that's okay? Okay, let's try one at our seats. Okay? Let's try doing, so I'm going to give you a binary number. I'm going to give you a binary value of not the same one. Okay, so go ahead. You can work with your partner on this. Try to figure this one out. So write the number down, and then go through the steps slowly. First time you see this, you know, it's funky. It looks like a foreign language. Convert this number to decimal. Everybody try it. Convert this number to decimal. We did that. Okay. Okay, so how are we doing? How are we doing? So you make sure now, start at the right. Draw your, this is sort of like a bookkeeping thing. Start at the right, go down, draw your digit down, take your value down, compare answers with your neighbor, see if you got it right. Okay? Okay, take your next value down. So you're doing it a different way, or?
No, I'm doing it. I'm just not writing it out.
Okay. Okay, everybody's getting, is that what everybody's getting? 30? 46. Oh, I'm looking at the wrong one. Okay, 46. Yeah, everybody get 46 and see why? You getting 46? Okay. Get it? No, what don't you get? 0 times 2 to the 0 is 0. 1 times 2 to the 1 is 2. 1 times 2 to 2 is 4. 1 times 2 to the 3 is 8. You're doing it right. 1 times 2 to the 5 is 16 times 2 is 32. Yeah. Okay, we're doing okay? Let me know if you need help. You doing okay? Looks like you're okay. Try this. Do not be afraid. Okay, 46. Good. Good. Okay, what did you miss? Oh, okay, there. That'll do it too. Okay, so let me go over this one. We'll try another one. So the way to do this is 0 times 2 to the 0 is 0. 1 times 2 to the 1 is 2. 1 times 2 squared is 4. 1 times 2 to the third is 8. 0 times 2 to the fourth is 0. And 1 times 2 to the fifth is 32. So you add that all up and get 46. Okay with that? Okay? Okay, so let's now move to the alternate. We're going to practice. We're going to have lots of practice. Okay? Let's move to the alternate conversion, which this is the hardest one we're going to do out of all the conversions. And this is going to be decimal to binary. Now remember, if we went from binary to decimal by multiplying by 2, right? Went from binary to decimal by multiplying by powers of 2. How do you think we're going to go from decimal to binary? Divide by 2. Okay, now this is the hardest. It's not hard math. It's just funky. That's not hard math. It's just funky. So the first example we have here is 19. Let me show you how you do this. So if I have decimal number 19, and I want to find out the binary value, what I'm going to do is I'm going to draw this like kind of old-fashioned divide. Divide by 2. Put the answer down here. So 2 into 19 goes how many times? 9. And what I'm going to do is I care about the remainder. I'm going to write the remainder out to the right-hand side. Okay? And then I'm going to repeat the process. So 2 into 19 goes 9 times, which is 18. I had 1 left over. Let's repeat this. 9 divided by 2 goes how many times? 4. And the remainder is, okay? 4 divided by 2 is 2. Remainder is 2 divided by 2 is, remainder is, you're not done yet. This is where people get screwed up. They get at the end and they like panic. No panicking. Okay? So 1 divided by 2 goes, how many times does 2 go into 1? 0. And the remainder is, and the answer is backwards this way. Can you guys see in the back corner there? The answer is backwards this way, 1, 0, 0, 1, 1, which is the same thing that's on the board here. It's the binary equivalent of 19. You read it backwards. Backwards. So 1, 0, 0, 1, 1 is 19. Well, the 2 just says that's the base. You want to try one? Questions so far? Now, this is just tedious. It's not hard math. We all know how to divide by 2. It's just kind of a bookkeeping thing that you have to kind of keep straight. The problem is if you make one mistake, then your answer is wrong. I'm going to show you how to check your work, okay? But first, let's learn the method. All right, so let's try at your